Hi guys, welcome to the lesson H1-7 on graphing linear equations on the graphing calculators. This video will focus on the TI-84 or 83 or 84 plus CE, all those Texas Instruments family of graphing calculators. So if that's the calculator you use, you're in the correct video. If you use one of the other calculators like the TI-Inspire or the Desmos, you need to switch to the other video. All right, today we will look at the following skills on the graphing calculator: graphing linear equations, looking at appropriate viewing windows, identifying the x-intercepts and y-intercepts, and finding intersection points. All right, looking over here, I have a lot of information written here, so you may want to just pause the video and copy it down. I'll go through it real quick, but then we will talk about this as we do some of our problems. First of all, to graph on the TI-84 family of graphing calculators, right, you turn it on, and when you're in your home screen here, if you want to put something in, you're going to press the Y equals button. That brings up the input menu. You see I already have a function in there. If I want to view that function, I just press graph, and you'll see that that function is already on the graph. If I don't want that one on there, I can actually highlight the equal sign and turn it off if I don't want to clear it out. Notice now it's gone, but the function is still typed in there. If I want to just clear it out and it's in there, I'll just, press clear on it and it clears it out. Okay. To adjust our window settings, and I'm going to throw that graph back in just so you can see what I'm talking about as I'm doing this. Okay. To check our window settings, okay, we can go into window, and it tells us that our coordinate plane, or that window that you see, goes from -10 to 10 on the x-axis. So that means this is -10, this is +10, and then the same thing, our y min is -10 and our y max is +10. So it goes from -10 to +10. The other stuff on the screen, this is the x scale. Okay, what that means here is all these little tick marks you see on here are going by ones as you go up. Same thing here with our x-axis. So on the y and the x, the scale's 1, it's just going up by ones. You can adjust that and change it. Let's say I wanted to make it go by 2s. There should be, half as many on there. You'll see there are half as many tick marks on there, but every one of them is now 2. Okay, if you're ever in a different window and you want to get back to the original window for this one, you can actually move your window around by using the zoom commands. And we'll talk about some of these later on if you have questions. But the main one I want to point out to you, if you want to go back to your standard -10 to 10 in both directions, that's zoom 6. If I press zoom 6, I always end up back here at that standard window. All right, so you see here, boom. I can zoom in and out. Let's say I wanted to zoom in. I go in here. If I just press enter, it's going to zoom in closer on my graph. Notice now my window has changed. Okay, I'm like, oh, I didn't want to do that. I need to go back to that standard window. I just press zoom, and then I press 6, and it takes me back. All right, then down here, when we're given x's and trying to find y's, we're going to use the trace command. So the trace button is right here. If I press trace, you'll see it, cursor pops up. And if you use the left and right arrows, it's going to trace the graph. It's going to go up and down, and it's going to tell you what exact point you're at as you're going through it. Notice it's very, very precise. It's got, exact, with the decimals and everything going as far as it can. Okay, so you will use that at some point. If we had another function on the graph, let me put another one on here. Let's say y is equal to -3x. I'll just put enter there. Okay, and if I look at my graph here, now there's a second graph, right? If I'm still in that trace mode, I'm like, I want to trace the other graph. Okay, left and right traces this graph. If I want to go to the other one, I press up or down, and it jumps to that graph. Now left and right will trace this graph. Okay, so just something that we want to make sure that you're aware of so that you can use your calculator properly. You want to go back, just press up or down, and it jumps back. Okay, so if we were trying to find x values, we'll get to that part here in just a moment when we get into some of the problems rather than re-explaining it a couple times. Okay, if I want to find the y values on a graph, I'm going to type in a new function, and then I'm going to treat it like a system of equations, and I'm going to find the intersection points. And that menu will be found under second trace. If you press the second button and you go to trace, now we're in the calculate menu, and there's some different options that we can find here. And I'll show you how we can use that to find our x-intercepts and our y-intercepts and everything here in just a moment. All right, so let's jump into the next part for now. If we look down here, so our standard viewing window goes from -10 to +10 in both directions on the TI-84s and 83s. Okay, you notice here, if I had a function that was graphed right here, okay, I wouldn't want to copy this down if I was asked to graph something. I wouldn't want to copy this down on our paper because we consider this to be like an inappropriate viewing window. Our goal when we graph something and we write it down or we sketch it on our paper is we want to be able to see both the x-intercept and the y-intercept. On this one, we can't see that y-intercept, so we would need to adjust our windows. So you see here, if I moved my graph down farther here, let's say I made my y minimum much lower than 10, let's say we made it like -15, maybe now I could see the y-intercept as well. Okay, so sometimes we have to adjust it, but an appropriate viewing window, you need to be able to see the x-intercept and the y-intercept of the graph. So let's look at a few problems here so that you can get a good feel for using your graphing calculator. So graphing linear equations. The first one we're going to graph is y equals 5/6 x minus 11. All right, so I'm going to go to my y equals. I'm going to press clear on anything that's in there. Okay, if you have any of these plots turned on, you'll want to turn them off. Okay, that's for graphing box and whisker plots, scatter plots, that kind of stuff. We do not want those on right now. So just highlight them and press enter. I'm going to type in 5/6 x minus 11. Now the calculator knows order of operations. I can do 5 divided by 6 x minus 11, and it knows that that is 5 divided by 6, and then that value times x minus 11. If you get a little hung up on those, a lot of the calculators will allow you to do alpha, and then you're going to press y equals, and it's going to bring up these function commands at the top. If you want to use this, like this, we call this math print. If you want to use the math print, you can go in there and do number 1, and it's going to allow you to type in the 5/6 the way that you maybe want to see it as an actual fraction. So if you get hung up on that, you can go in and do that for most of the TI-84 models. TI-83, you will not be able to do that if you're using a TI-83, but TI-84 you can. If yours doesn't, bring it to me, and I will update the operating system so that you are able to do it. Now, when I graph this, we'll see our function will come up, and we consider this to be an inappropriate viewing window because I can't see the x-intercept or the y-intercept. So the two ways we could do this here, it looks like we need to move it down a little bit. I can go into window, and if I need to move my y min down to maybe -15, let's see what happens. Now I can see the bottom. I still can't see this side, so we need to extend it out to the right. So we'll press window, and we need to change our x max, and let's try 15. Right, and then when I press graph, you'll see it shows up. So our window now goes from -10 on the min to 15 on the x max. It goes from -15 on the y min to +10 on the y max. And we can take it and we can just sketch that graph on here. So our x-axis is a little bit offset to the left. I'm sorry, our y-axis, a little offset to the left. And our x-axis is a little offset on towards the top. So I've got my y-axis, I've got my x-axis, and then I'm just going to kind of sketch the line in here. It looks like it goes up and looks like that. Now, to find our x-intercepts and our y-intercepts on the TI-84 family of graphing calculators, okay, there's some commands you can use. Okay, if we go second, actually let's do our y-intercept first. Or y-intercept we're going to do first. If we want to do our y-intercept, we can actually press trace. Okay, notice now we can move it back and forth on here To get our y-intercept, sometimes you can land right on there, but notice it's so exact that it's having trouble getting right on the y-axis. So here's what you can do. You can either do second trace and go to value, number 1. It says, well, what is x going to be? Well, remember, your y-intercept, the x-coordinate is 0. So if you put in 0, press enter, it's going to tell you exactly what the y-coordinate is going to be, or that output at 0. So we have the y-intercept is at -11. And you might have already known that because it's in slope-intercept form, but that's okay. And then to find our x-intercept, though, it's a little different. So if we're going to go in here, and to find our x-intercept, okay, we need to go second, trace to the calculate menu, and you'll notice here the second one says the 0. Okay, now we didn't write this at the top of our paper over here, so if you need to jot it down now, you can. But if we press 2, remember, a 0 is like a root or an x-intercept. So what it's going to do now here is you see it says the word left bound. Because what if you have more than one x-intercept on your graph, right? If there's more than one, what they want you to do is create a region for it to look for an x-intercept. So we're going to create a little window for it to look in. So my cursor is on the left side of my x-intercept. I press enter. Notice it's started, it's marked the boundary here. Now we're going to move it. It says right bound. So we want to put it on the right side of our x-intercept. We hit enter. And now the calculator is going to look between this region here for the x-intercept. You hit enter one more time, and it tells you that your x-intercept is 13.2. So we'll copy that in here. So if you need to pause the video or rewind it there to make sure you write down those commands, remember for our y-intercept, we could go second, calculate here, go to the value menu, okay, or our x-intercepts, we go second, calculate, and we go to the 0. Now, just one little trick here for your y-intercept, which might even be easier for you. If you press trace, right, remember this allows us to trace it left and right. While you're on there, you actually don't even have to go into that value menu. If you just type in a number, like 0, it'll automatically calculate it for you. X equals 0, boom, that's our y-intercept. Okay, so when you're in the trace mode, if you just enter in the number, it'll treat it like x equals that number and then give you the output. So let's find some values here. First it says find if x is 6, y equals what? Well, since we're still in that trace mode, let's just go ahead and type 6. It says x is equal to 6. Our y value is -6. If x is 3, what is y? Well, we'll just, since we're in the trace again, right, we're just going to press 3. And our output is -17/2. Okay, so that's like -8.5. So you can write either one, -17/2 or -8.5. And now to find when they're giving us y values, we have to do this one a little different. And that's why I made sure we wrote this down up here. Okay, so if we want to figure out if y is equal to 8, what is x? Let's go to y equals here, and let's go down to a new input. Let's put in y equals 8 and press enter. Now you're going to see on our graph we have another line that showed up. However, can we see the intersection of those two? We cannot. So we need to extend our graph over, or here's what you can do. Little trick, let's just zoom out. Zoom number 3. Okay, we're way out now, but now we can actually see that intersection. Right, so we know that intersection is going to be here. So here's how you find the intersection of two graphs. Okay, so we're going to go to second trace, and we're going to go to number 5, intersect. Just press it. So on the bottom of your calculator, after you've pressed it, it's going to say first curve. It considers each of these a curve or a different function. If I press left and right, notice it just traces it. I want to find the intersection of this function that it's on right now, so I'm going to just press enter to mark that function. And you notice it jumps up to the other function. Now look, left and right traces this one. So I want to find the intersection between these two, so I'm going to mark this function by pressing enter. Okay, it always gives a guess. Honestly, I have no idea why. I've always wondered that for years, but it's cool. And then we're going to just press enter one more time, and it's going to tell us our intersection of those two functions is at 22.8. So when y is 8, x is 22.8. Now it wants to know, what about when y is -2? So just go back in. Let's change that 8 to a -2. Hit enter. Let's graph it. Go and look at the graph. And then again, it's second trace to the calculate menu. We want the intersection, so number 5. Mark the first function. Now it's on the second one. Hit enter, and then hit enter one more time. And we see that when y is -2, x is 10.8. And we got it. So let's move on. Uh-oh, where's the other page? Oop, it's on the back. All right. Whew. Okay, I don't know that we'll do all these, but if you're feeling like you've got a grasp on it already, okay, you may go ahead here and pause the video and try it. However, there's some things that you may want to hear, so that's up to you. For the next one, I need to go in. We need to clear out what we've got in here. Now, here's the only thing with the TI-84 models is, remember, everything has to be in y equals form. This function is not in y equals form, so for you to be able to enter it in, you need to take it and get y by itself. So how do we get y by itself? We're just going to divide everything by 3. So when we do that, we should end up with y is equal to, this would be a -1/3 x, and 66 divided by 3 should be 22, so plus 22. So make sure you do your math right so that your graph ends up being correct. Let's type that in. So I'm going to do -1 divided by 3 x plus 22. If you need to type in the fraction, remember it's alpha y equals to type it in using that math print. Graph it. Oh, I forgot to change my window. But it looks like we can almost see everything there. Let's see what it looks like in the standard window. Right, we can't see it. So if you get that and you're like, it's not working, my calculator's not working. No, it's just because it doesn't fit in that window. So we know here that we can either zoom out, hit enter, see if that does enough. Right, we can see the y-intercept there, but we can't see the x. So maybe now we go into window and we just need to increase our x max. Let's make our x max, let's try 50 and see if that worked. Looks like that wasn't enough, so then you can just go in there and add a little bit more. Let's do like 70 just to be sure. Let's see, I think that should work. Yep, it makes it there, just barely. If you wanted to make it farther, you actually could, but I'm gonna go ahead and use that one there. So my x min is -40. My x max is 70. My y min is -40. And my y max is +40. So when we're sketching this graph, this helps somebody see what you've got, because when I draw on my x-axis straight across here, right, I know that it's right in the middle, but the bottom could be -10, top be +10 or whatever. So this gives us those details so somebody who's looking at your graph understands that it's zoomed out. Okay, and then our y-axis is a little offset to the left here. And it looks like it goes down, it crosses right before the bottom here. So I'm gonna just take it and do straight down like this. And if it's not absolutely perfect, that's okay. Remember, it's a sketch. But this is my x-axis, this is my y-axis. And so now I can see my y-intercept and I can see my x-intercept there. All right, so let's figure out what those are. So y-intercept, remember I can do trace or second trace value. I'm going to type in 0 as my input. When x is 0, y is 22. My x-intercept, remember second trace, go to 0. And then we need to put boundaries on both sides. So I need one on the left side. This one's already on the left side, but I like to make it just a little closer. And then I need to move it on the right side. So that looks like, so I'm definitely past it there, so enter. So now it's gonna look between that region and you get 66. So our x-intercept is 66, 0. Okay, now, if x is 20, what is y? Well, remember, if we just press trace, we can say when x is 20, just type in the number, hit enter. Y is 15 1/3 or 15.3 repeating. X is 84. Now, I don't think that 84 fits on there, so let's see what happens if we do that. Let's do trace. We're already in the trace mode, right? So let's do 84. Let's see if it gives us 80. Oh, there's a problem. And the reason there's a problem is because our window max, right, was 70 for the x. So what we're going to need to do is we need to make it so it's beyond 84. So let's just change our window. So we'll quit. Let's go to window. Let's make our x max. Let's just make it 90 so it's got that room. All right, we look at our graph now. Okay, 84 is going to fit. So let's do trace. Type in 84, hit enter. And it tells us the y value would be -6. So you see there, if that value doesn't fit on the graph, then you're going to have to adjust it or it's going to tell you there's an error. All right, and then to get our y values, let's go in here and let's do y equals 18, graph. There it is. Second, trace, number 5, intersect, enter, 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 and we get that x is 12. Then the second one, go back in, change it to 23. Look at the graph. Okay, it fits on there. You can see that intersection point. And then we'll just go second, trace. We'll go to intersect again. We're just marking the first function, the second function, and then enter the third time. And it tells us that when y is 23, x is -3. All right, so that is all the information for that one. We'll probably do, we're not going to do all these examples. We'll do number 3, and then let's say we'll do maybe number 5. Okay, so if you want to try number 3, remember the first thing you're going to have to do is get y by itself. So while you're doing that, I'm going to go ahead here, clear this one out. All right, so in doing that, right, if I want to get y by itself, it's really not that bad. We need to get rid of the x over 2. So if we subtract that from each side, we now have -y/3 is equal to -x/2 plus 8. And to get a positive y over here, we need to multiply both sides times -3. So when we do that, we're going to have a positive y. On this side, we're going to have -3 times a negative is going to be a positive. So we have 3/2 x. And then -3 times 8 would be -24. That's probably the only downfall to the TI-84s is the fact that everything has to be in y equals form, where some of the other models, you don't have to have it in that form. But this is a good thing to be able to do. So let's type it in. I'm going to do the fraction mode on this one since I didn't on the last one. We got 3/2 x minus 24. And graph it. Okay, notice I'm still in my old zoom, so let's just go back to our standard zoom and see what that looks like. So just barely squeaked in down here. So we know our y-intercept is going to have to end up being down at -24, so we need to go definitely below that. So let's say here, window. And you can do the zoom out if you want. I'm going to just do -30. You can see here now, I can see the y-intercept, and I'm going to need to move the x over a little bit. So let's do, heck, let's just make the x max 30 as well. Just, that way I just made it the same numbers. Cool, looks like it fits right in your window. So you've got negative 10, positive 30. You have negative 30, positive 10. Now you can sketch your graph. It's going to be offset here. We've got our x-axis up here, y-axis over here, and it looks like our graph runs something like this, up this way. So this is x, this is y, and then that's our function. Let's find the x-intercept and the y-intercept now. Okay, so x-intercept, second trace, doing our 0. Sorry, I didn't realize my calculator was off the screen a little bit. That's a bummer. Got your left boundary, create your right boundary, and then enter one more time to find it. Looks like our x-intercept is 16, so we have 16 comma 0. Y-intercept, remember, just press trace, type 0. When x is 0, y is negative 24. And then to find the values here, when x is negative 4, well, we're still in trace mode, so just type negative 4. Boom. When x is negative 4, y is negative 30. When x is 25, y is 27 halves, so that's like 13.5. Or you could write 27 over 2, I don't care. Now, if y equals negative 10, what is x going to equal? So think about it for a second. Do you remember how to do that? Remember y equals, go down, type in negative 10, hit enter, graph it, you'll see the intersection, and then remember your commands, second, trace, number 5, intersect. There's only 2 functions on there, so enter, enter, enter. And it looks like it's about 9 1/3 or 9.3 repeating. Second one, go down, change it to negative 20, graph. Same command, second, trace, intersect, enter, enter, enter. And you see you get 2.6 repeating, or 2 2/3. And that one's done. So hopefully you're feeling pretty good about this. There's one last little thing that we need to make sure we talk about here. So hopefully you've made it this far into the video. Let's look at finding intersection points. Okay, so we've kind of done that already, but this is just given 2 functions. What's the intersection point? What's the solution to this system of equations? So the first thing with the TI-84s is we need to make sure we put these into slope-intercept form first. So take the time to do that. Right, we've got 3x minus 2y equals 6. So you go to negative 3x plus 6. We divide it all by negative 2. So y is equal to 3 halves x minus 3. That's our first function. And then the second function, we can do it here right beside it. We've got 5x plus 3y, I'm going to just say equals negative 9. We have 3y is equal to negative 5x minus 9, divided all by 3. And we've got y is equal to negative 5/3 x minus 3. All right, let's graph them on the calculator here. So let's go make sure everything's in there. Let's clear out what we've got. So we need to graph both functions. So we're going to do 3 halves x minus 3. And we're going to do negative 5/3 x minus 3. Graph it. Okay, we can see it on there, but let's just go back to our standard zoom window. Oh, that's better. All right, so let's sketch that graph on here. We've got our y-axis. We've got our x-axis. Now, if I don't give you a spot to write all this information down, you can just jot it on here. You can say this is negative 10, positive 10, negative 10, positive 10. And it looks like our graphs come down this way and that way. And it looks like our intersection point is right on the y-axis, which makes sense, right? They both have a y-intercept of -3. It's probably not the smartest problem to pick for me, but whatever. Here's how we find the intersection. We go second, trace, intersect, just like you were doing with the finding the x values. Okay, so we go number 5. Notice left and right is giving me, I'm on the one function. If I press up or down, it jumps to the other one. I haven't marked any functions yet, but I'm going to do enter, 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 and it tells us the intersection is at 0, -3. So it's asking what are the key steps to find the intersection. You're going to graph them both, and then you're going to do second, trace, number 5, intersection, right? That's intersection, and then enter, enter, enter. That's times 3, or 3 times there. All right, that's the end of these notes. There isn't really an assignment for today, so hopefully you've been practicing along as you've been doing it. If you have any questions, please reach out to me. All right, otherwise, thanks for watching.